Okay, and we are broadcasting. We are live on the web. All right. All right. You can see yourselves on TV. I'll post the link on from YouTube afterwards, so anyone who missed it or wants to revisit can check back. So, like to offer the warmest welcome to Auriel Fournier, Dr. Auriel Fournier, who just finished her PhD at the University of Arkansas at Fayetteville. Now, she is going to be talking to us today about using open workflows in her PhD work and how that's changed her practice. So I'll let you take it away, Auriel.
Okay, awesome. Thank you so much. I'm really excited to be here today to talk to you guys. It is echoing quite a bit now. Sorry, Kristen.
Okay, yeah, here, I will mute us. And that way, okay, and then if anyone asks a question.
Okay, cool. All right, I can't hear myself talking now. Much better. Okay, so hello everybody. I'm really excited to be here today and get to talk to you guys a little bit about how I've been using open science and kind of reproducible methods in my PhD work and how I'm going to be continuing to do that throughout my postdoc. Kind of thought I would start out today just giving you a little bit of background on the kind of work I do and then how that fits into kind of an open and reproducible framework. So my PhD work is all about studying bird migration and wetland management, specifically in Missouri, and looking at autumn migration of these really goofy little birds called rails, which are a family of birds that for the most part live in wetlands. And they're really secretive and really elusive, and as a result have what is known as really low detection probability, which means that when we go out and we look for them, we have a pretty low chance of seeing them, even if they're actually there. And so as a result, we have to use a lot of really specialized field methods and also really specialized statistical methods to kind of deal with that problem to let us really study them. Which has been a big part of what my PhD has been looking at and is one of the big reasons that I got into using R and kind of using reproducible science in general. So one of the kind of big reasons that kind of open and reproducible science is so important for studying rails specifically is that they're very poorly studied, mostly as a result of them being really difficult to study and the fact that we need some pretty advanced statistics to be able to do so. And so all of that has kind of come about in the past 20 years or so. So unlike most birds in North America, which have been studied for a really long time, rails are still pretty well unknown, which is exciting as a PhD student, but also comes with its frustrations. So I originally got into using R, which is the platform that I use to do most of my reproducible and open science, because of the package Unmarked, which allows us to do hierarchical modeling, which is the way that we deal with taking into account detection probability when we're trying to model abundance. So I go out and I do these surveys, and then I'm able to take those counts and some other information to estimate detection probability and then estimate abundance and then answer questions about their habitat associations and how that changes over time. But I originally got into that because to do that, I have to be able to use R. And so my first 2 years of grad school were a throw myself into the deep end and learn how all of that works. And from there, I got involved with several different groups online who were kind of focused around that unmarked community. So it was very much method driven at first, but I very quickly learned how powerful R was for a lot of other tasks and how frustrating it was to constantly have to go back and change things by hand in Excel and in other software. And so I started kind of expanding into R more and more. And then a couple of years ago, Christy and a couple of others suggested that I get involved with software and data carpentry as an instructor. And I've been an instructor with them for 2 years now, which has been a really amazing experience and has taught me a lot more about a lot of other tools like Git and other forms of version control and about using the Unix shell. And all of that has become really important for what became a big part of the second part of my PhD, which was taking advantage of citizen science and other open source sources of data. So if you're not really a bird person, you may not be aware of something called eBird. It's run by Cornell, and it's a citizen science database excuse me, it's a citizen science database of observations from birders all over the world. You guys could create an account now and submit the birds that you see when you're walking around campus. And so all birders from all over the place, as they travel around and do things, are submitting their observations, and then that data is openly available for anybody that wants to use it. And so I've been using data like eBird, and also data from historical ornithological records, and also from bird building strike programs, which is another thing you may not be familiar with. So in a lot of big cities, there are programs where people will walk the same block of the city every morning and record what birds have hit buildings, because birds hit buildings a lot, especially during migration. And that information, you know, while it is incredibly unfortunate that so many birds hit buildings and a lot of them end up dying, we're at least able to kind of gather that information. And so I've been bringing together historical ornithological records, building strike records, especially from Indianapolis and Chicago, but also from a couple other bigger Midwestern cities, and eBird data to try and better understand migration of these birds outside of just Missouri. And working with a lot of different data sources can be really exciting, it can be really powerful, but it also has a lot of struggles, and that's where working in this kind of reproducible framework has been really, really helpful. Because these data sets are constantly growing, and I've been working with them for about 3 years now, so about every 6 months I get more data from these different sources, and I need to be able to integrate it into my master data set pretty quickly so that I can keep moving forward with my research. And through scripting things in R and using a lot of different data cleaning techniques through R and other open platforms, I've been able to do that in a way that is much less frustrating for me and also a lot faster, which has been really, really, really wonderful and really powerful. So yeah, that's kind of the big way that I'm involved with kind of open data. I've been becoming involved a little bit more with package development, with some with the unmarked package, and with some more kind of specific little packages that are very helpful for different kinds of ecological statistics, which I think is really exciting. And then for my postdoc, which I'm going to be starting a week from tomorrow, which I'm going to be moving to Mississippi for that, I'm going to be doing something called structured decision making. Which is something that most people in kind of the ecology world are pretty unfamiliar with. But structured decision making is where we take a whole bunch of different objectives and alternatives for making a decision, and then we weight different priorities, and we can use a model to help us make informed decisions. This comes out of the business world and the medical world, and is now being used more and more in ecology. And I'm going to be using it as part of the Gulf of Mexico Avian Monitoring Network. So the BP oil spill happened back in 2010, the Deepwater Horizon oil spill, if you will. And part of the reparations that BP had to pay was a very large sum of money, some of which has been set aside for bird work. And I'm going to be working on models that will help the government and other partners make informed decisions about how to spend that money. And we're going to be doing all of that in an open framework and building some kind of open framework tool, I think probably through Shiny, but that all the details of that are still being worked out, so that people who are making the grant decisions can go in and rank grants based on a bunch of these different criteria and be able to incorporate. So we're spending a lot of time talking with stakeholders, talking with granting agencies, talking with the public to try and understand how they value different parts of the environment, both, you know, intrinsic things like I like seeing birds, and also really important ecosystem services that those birds provide. And then the granting agency can go through and say, well, this grant hits these 4 priorities, this grant hits these 5 priorities, which one is more important? And the structured decision-making model will help them to make those choices. And we'll be doing that in an open framework as well. But, you know, kind of having experience working with open tools and having kind of a track record online of doing open tool work was really important in me getting this postdoc. So it can have really good long-term benefits. And plus the community around it is just really, really wonderful, as you guys have seen, since, you know, you have Christy as an instructor and she's awesome. So, but yeah, I guess I was kind of curious to see what kind of questions you guys might have for me, and then I could maybe talk more about one of those things than the other. I guess I don't totally know what you guys have already talked about in class, so I didn't want to repeat myself or repeat what you've already heard too much.
There, unmuting.
Great.
Okay, so any questions? Yes, yeah.
My question is about how seamless you anticipate the open science process will be at your postdoc. Specifically, I'm wondering about like agency review. things like that. My experience working with agencies is they don't want you to communicate necessarily directly. They want to review everything before it goes out.
Yeah, that's a really good question. I'm currently with the federal co-op here at the university, so I'm pretty familiar with kind of some of those barriers and how they can work. For this tool, part of it will probably be developed in a very open way. Some of it's already been under development, and so a lot of that review steps have already been gone through, and they're kind of hiring me on at the point in the process where they want to take it from, you know, being all of these meetings that they've had and conversations that they've had with people and turning it into the tool, which is going to be an inherently open tool. And so there will be a review, but it's going to be going through that review while it's out in the open. And part of being out in the open is getting feedback from, so this monitoring network composes all of the state agencies for all of the Gulf Coast states. It also involves all of the Mexican states. It involves Cuba. It also involves a bunch of different nonprofit partners and the Fish and Wildlife Service and USGS. So there's a lot of different feedback and review happening from a lot of different places. But my understanding right now is most of that will be happening in some kind of an open framework. But that is a very good question. And yeah, to some extent, there will probably be some review happening before some things go online. But as I understand it, most of it will be happening in an open way. But I'm sure I will learn more about that in the coming weeks since I actually haven't started yet. So.
So what made you choose that position? Because I know you had several opportunities present themselves.
Yeah, well, I really like big scale projects and I really like collaborative projects. And so this would really fit kind of both of those things for me. You know, thinking about conservation and especially trying to establish a monitoring program at the scale of the Gulf of Mexico is a really big and really fascinating question to me. I also like really applied work, and this is a very inherently applied project. And structured decision making is something I've been interested in for a really long time. And so I'm really excited to get to spend 2 years kind of digging deeper into it and better understanding it. Plus, I'm going to get to keep working kind of in an open framework and keep developing that skill set, which was really important to me as well. Yeah.
Any other questions?
Sure. About the, sort of continuing with the agency theme. Maybe you don't even know the answer to this question, but about the IT policies with the agencies you're working with, I know sometimes those can be very strict. Like they'll say, I'm only in AS shop and you can't use anything but ArcGIS, that kind of thing.
So I am actually working for Mississippi State. I'm not actually working for a particular agency. So I think that will help alleviate some of the IT issues. But I haven't actually started yet, so I'm not sure what unique bumps in the road, you know, Mississippi State computing will present. I know there have been certain bumps in the road here at the University of Arkansas with software that we can and can't use, and I'm sure that will, you know, that's true everywhere. But the fact that I'm going to be working for a university technically on a university machine will probably help in part.
So you're an ecologist by trade, right? That's what you got your PhD in?
Correct.
So how did you make the transition into the IT world? What kind of training did you receive?
For kind of the first 2 years of my PhD, I was largely self-taught. I had a friend who was also starting graduate school around the same time, and we were both in very kind of quantitative, computationally intense projects, and so we kind of helped each other learn. And then around the third year of my PhD, when I started to get involved with software and data carpentry, I also kind of discovered, you know, this great big community of people who have a lot of material available online, and I started to learn a lot there. But for the most part, I've been self-taught. The University of Arkansas doesn't really offer a lot of courses. I've been able to take some workshops different places, but those have been mostly focused on certain quantitative methods, as opposed to, like, you know, coding in general. So yeah, it can be an intimidating hill to climb by yourself, but it is possible.
Well, it's lucky that these guys now have a local network that they can tap into.
Most definitely, that is very helpful.
So what kind of challenges did you have during your PhD with using open frameworks?
I think
You don't have to name names.
no. So one of the first challenges was that there's a statistician in our ag stats department that I work with fairly regularly, who's really wonderful, but his entire background is in SAS. So we would sit down and we would talk about, what exactly I should do. And then he knew that, I don't have access to SAS and that I wasn't going to be using it. So it was like, okay, cool. Well, I need you to do this model with this this structure and all of this. Go figure out how to do it. So that was kind of one of the big struggles, but I would know, conceptually what I needed to do, but the actual implementation was, entirely my problem to solve. So we have gotten some newer faculty in the past couple of years who have been able to help in some ways. But when I first started, there wasn't really a lot of use of open software in the department. So, so yeah, that was one of the big challenges, at least initially.
Yeah, did you ever get stats classes? Like, what language did they use in your stats classes?
We use SysStat.
Okay.
Yeah, we've since moved that class over to R because I was the TA. But when I took it, it was SysStat. So,
yeah, it's funny talking to a variety of biology and natural resources type departments lately. They either have made the change or are planning on making the change. They kind of feel a pressure, but they, sort of say, okay, well, this is what we have right now. How do we make this transition?
Yeah, I mean, and it's
difficult. Sorry, so do you have any advice for departments that are making transitions?
I mean, I think for our department, the big thing has been kind of making it all happen at once and not having classes taught in different softwares, which kind of involves you making a big change as opposed to smaller changes, because otherwise students have to learn multiple different softwares or multiple languages, which is confusing and possibly incredibly unhelpful depending on what that student's goals are. But at a very minimum, it's very confusing. So, and I would also say if you don't have anyone in your department who's capable of teaching those workshops, bringing in something like software or data carpentry and putting a bunch of students through it so that they can peer mentor each other is also really helpful. We did a software carpentry workshop here at UA 2 years ago, and that really helped kind of move our department along because suddenly we had 40 students who had been through that 2-day experience and kind of had an understanding of, at least at a base level, what R was and how it worked, which helped a lot. We also had 2 faculty go through that workshop, which was also a big help. So there are ways of kind of, helping push people over the edge with kind of an intensive 2-day experience. But it does require faculty in some cases to learn something new, which I can totally understand why not all faculty are open to that because they have a lot of things on their plate and learning R is not a small task. So it's difficult, but I think it's important.
Yes, Eli.
Could you elaborate a little more on what the role of the software and data carpentry in developing your skills and getting to where you are now?
Sure.
Oh, okay, good.
Yeah. So when it comes to R, pretty much everything I knew about R I didn't really get from data and software carpentry. But data and software carpentry is what really pushed me to better understand how version control works and to finally start using it. Because I knew about it before I started teaching, but then when I started teaching, I had to teach it, which forced me to learn it. And then once I finally got over the hump of learning it, I started using it. Now I use it pretty much every day. Excuse me. And the same is true for the Unix shell. I use that on almost a daily basis now as well. So it's been really good at pushing me to use more and more open tools and also kind of giving me an excuse to devote the time to learn them. The same has been true of learning OpenRefine and learning a little bit about SQL. I got to teach those lessons at workshops in the past 1.5 years. And, before I taught those workshops, I'd never really used them before. I usually get brought into workshops to do the R stuff, but sometimes I do one of the other lessons as well, which has been a really good experience for me to kind of develop those skills more broadly. Does that answer your question?
Yeah, thanks.
Yeah, I do not cover SQL and the Unix shell, for instance, in this class because I'm sort of choosing the skill sets that I feel are most relevant to me. But if you guys wanted to, I could learn some of those a little bit more in more detail because I've always been the person who teaches the R lessons within software data carpentry.
Yeah.
And then the spreadsheet lessons. Yes, Braden.
Hi, have you found that using new software like R, and I mean new as in the like faculty at your university might not be familiar with it. Do you feel that that has driven you to ask different scientific questions than they ask, or do you feel that you just approached the same scientific questions differently?
That's a really interesting question. I guess it's, no, go ahead. Sorry, I'm just thinking.
Take a scientific question and then say, okay, how do I use R for that? Or are you playing in R or playing with some of your open science resources and think, oh, I can do this cool scientific thing that I never thought of?
Yeah, I mean, for the most part, it's the first one. Usually it's, I need to analyze these data. What is the best way to do that? Okay, I need to use this kind of a model. How do I implement that model in R? But in some cases, it does come the other way around. It's like, oh, you know, someone I know has developed this really neat tool, and now I would like to use that tool. In my experience, like using a friend's tool has come up most frequently in doing things like graphing and mapping more than in actual like statistics. And that might just be more the people that I interact with than anything else. But I have helped kind of develop new extensions for the unmarked package, and the things that I've helped develop have come out of needs that I've had in my research that the main maintainers of the package just haven't had time to do because they're both university professors and don't have infinite time. So, so a little bit of both, but mostly the first one, I think.
So what are the extensions you developed for unmarked?
Making it more generalized and making it so it was developed under a framework where you would never have a missing survey, which when you're a theoretical ecologist is great, but when you actually do field work, you realize is not possible. So I helped develop the tool to the point where it could handle NA values, and so that the modeling behind the scenes didn't just cut out all those surveys, so that it was actually able to handle them. And I mean, it's not as good as if you had a complete matrix with all of the data, but it will at least take advantage of those smaller chunks of data.
Mm-hmm. Yeah, that's important for realistic conditions.
Most definitely.
I think we're all dealing with spotty data in some form in our projects, right?
It's pretty unusual to not be dealing with that, yeah.
Isaac.
So I was kind of wondering, you said you are developing a package, not a package for R, right?
I can't really hear what he's saying, sorry.
Okay, so Isaac said that, so you mentioned that you're developing a package for R. He's right at the back of the room, so.
Yeah.
I was just wondering if, like, at what stage do you, like, start creating repositories on GitHub to document what you're doing? Is that when you start building up that package, or maybe halfway or midway through it, like when you decide to start creating a repository for mine?
Right, so could you hear that, or should I?
If you could repeat it, yeah.
Okay, so Isaac wanted to know, when you're developing a package for R, when do you start really documenting, making things public on GitHub? Like when you're about halfway through, like when the project is complete, or all the way along?
Good question. So in my case, currently, it depends on what project I'm working on. Some of my collaborators are more open to doing things in an open framework than others. So pretty much everything I work on is on GitHub, but some of them are in private repositories and some of them are in public repositories. And for the most part, I'm very comfortable with starting out from day one, putting things into a public repository, as long as it doesn't contain any like endangered species information or like personally identifiable information. You know, you have to take all those things into consideration. But for some of my projects, I have collaborators that for one reason or another are not comfortable with that. And so not until we actually like submit the paper for publication and I go to archive the data in the code does that end up being publicly available. In my ideal world, it would be all open all the time, but you know, I work with some people who have different philosophies and that's the world that we live in and that's okay. So it just depends.
Do you code tighter when your data is publicly on GitHub than when you just keep it in your private like server?
I certainly spend more time going back after I've written it and trying to make it cleaner. Whether or not that happens like right away or if it's more of like over time things get cleaned up. I definitely notice like projects that I develop open the whole way down. When I go to submit the final copy to Data Dryad when we publish, I don't have to do very much cleaning up. Whereas things that have been developed in a private repo, when we go to submit for publication, I spend a lot more time, you know, tidying them up and commenting them.
Right.
So it definitely does change the way that I code, which is unfortunate. I should really be good about it all the time, but I'm clearly not, so.
Back to switching the course, your stats course from C-Stat to R. How open was the professor to doing that? Because we have a similar situation in our department, and I've been thinking about helping to transition those labs over. But I don't know if it's individual, but I just wonder what your experience was.
Yeah, so he was very open to the idea, but wasn't willing to take on the work of transitioning the lessons himself, which is why I was able, you know, I was very fortunate. We have a lot of TA positions in my department, so I was able to get a TA position in his class. And so my job that semester was just transferring the lessons from Systat to R every week and then leading the labs. And so now everything's in R and it's documented, so when he teaches the course in the future, it's good to go. So in my experience, it wasn't necessarily a resistance to changing, so much a resistance to I do not have the time to make that change happen myself. And I don't know what the situation is for your guys' department, if that would be an option or not, but that's how I got it to happen, so.
Okay, thanks.
Yeah.
Yeah, I've heard that one of our grad courses is taught in SAS and one in R, right?
Mm-hmm. For what department?
Aren't they stats courses or?
Ours is
The stats course I'm in right now is SAS.
Okay. Yeah, it's interesting. There's a lot of stats departments that are still very entrenched in SAS. I think they still train a lot of their students in SAS, and so that's interesting.
Yeah, our stats department is still mostly SAS based. They're starting to do a little bit of R for the intro courses, but everything that's beyond intro stats is still in SAS.
Mm-hmm.
For the one place I've been able to find some kind of higher level R courses in our university has been in the geography department. They do a lot of spatial statistics, and so I've been able to go there and get some stuff.
Yeah, it's funny. Same here. Some of it.
I kind of got the feeling that it was more of a cultural thing about geography more than just our specific department, so that doesn't surprise me. They seem pretty, R focused versus other languages, so.
Yeah, I've seen a lot of resistance in the medical community associated with, well, SAS is a tested product. And so if we make the wrong decision based on, the algorithm that SAS uses, it's on SAS. We can sue SAS, but you can't sue R.
Yeah, I've heard that from a couple of folks in ecology as well. And I mean, if you aren't really interested in understanding what's going on in the background, I mean, I guess that's a fine argument to make. But I would hope that you would understand what's going on with your software well enough that you'd want to know what's happening. But I mean, everybody's got to make their choices on how they spend their time and what they do. I'm not here to put fiery judgment down on someone, but I find that argument a little concerning, I guess.
See, I'm here for that, so.
Yeah.
I think something to consider is if you're 55, 60 years old and you've been doing SAS for God knows how long, and now you're asked to switch. I mean, I don't think that's a good excuse for teaching because you kind of need to teach students what is relevant to their studies. And I think R clearly is the case for that. SAS classes are sad that they exist. But I think you gotta understand that for some of these people, they have binders of code that they've documented of things that have worked for them. And now you're asking them to learn a whole other language.
Oh,
It's like learning
definitely, yeah.
software, you know?
Yeah. I mean, like my new PI for my postdoc, like he's been talking about how like he really wants to learn R, but at the same time he can just hire postdocs who know it. So, you know, like he wants to know, but he doesn't have the time really. So I'll probably sit down and teach him some stuff over the next 2 years, but for the most part, he's just figured out, you know, I'm at a different stage in my career. At this point, I hire postdocs who know how to do the coding, and I think the big thoughts and get the money and help them do their thing. So, and as a postdoc who just got hired to do R, I'm totally fine with that. So.
Any other questions coming up? Yeah.
Speaking of well, sort of geography and mapping and things like that, do you map stuff, make your figures in R, or do you use Arc, or do you use Python or anything like that?
For graphing outside of mapping, I do everything in R. And for the most part, I do my map making in R now as well. But it really depends on what kind of map I'm making and what kind of computer I'm using. If I don't have a computer with a lot of RAM, I usually end up going back to Arc, because mapping in R when your computer takes like 5 hours to load your map is pretty frustrating. But I do like using R to make maps, you know, for the same argument you can make for making graphs. You know, it's nice to have it scripted and everything. But I mean, ArcMap is good at making maps. That's what it's designed to do. I just don't always have access to a license, so.
Thanks.
Yeah.
Anyone else? All right, so let's dive a little bit deeper into challenges. When you proposed new technologies over the course of your PhD, what was the general reaction?
I guess it kind of depends who I'm proposing it to. For a lot of things, like before I got really good at using things like Tidier and dplyr, people would be like, oh, well, I could just do this for you in Excel in like 30 seconds. And I'm like, yeah, okay, that's fine. I understand that you can do it that way, but let's be honest, my advisor's gonna want it done a different way in 3 weeks. And we're gonna have to do this again and again and again. So kind of convincing the people that I work with that the long-term gains came from doing things in a reproducible way was kind of the big struggle. But I mean, I guess I've just become known as the person who uses R for everything, so people no longer try and convince me to do things in Excel. I don't know if it's so much that I've convinced other people for the most part, but that was kind of a big challenge early on, was like, well, just give me the afternoon, I'll figure out how to make this happen. And they're like, oh, but I can do it in Excel. And I'm like, yeah, but I want to learn how to do this in R, and I'll figure it out. And the next time you ask me to do it, I'll just be able to do it. So that initial time investment was also one of the big challenges. But I was really fortunate in most of my PhD to be on an RA, so I wasn't teaching most of the time, so I had more time than a lot of my lab mates did, which also helped me a lot. So my experiences may or may not be totally applicable to your particular life, because I did have a lot of time, especially my first 2 years, to devote to R.
Kind of more of a fun question. What kind of, did anything break you to the point that you realized you had to use R in the future, or like come up with some sort of reproducible methods? Because as an undergrad, I was doing some modeling and things, and every time I did a new version of the model, it would take me like 20 hours to process everything. And that's what forced me, like once I knew that I could actually learn to code this sort of stuff, you know, and then that propelled me forward from there. Did you have a similar situation, or were you just wise?
I definitely wasn't super wise to begin with, and I still don't know if I totally count as being super wise now. for me, it was especially when I started working with lots of different data sets that I needed to bring together, and the fact that those data sets were growing over time and involved lots of different files. And so I learned that I could build scripts so that every time that I got a file from eBird and the building strike people, I could just dump it into a folder and run the script, and it would check it for errors and bring it all together. And I was like, whoa, that's really cool. When I was doing the other stuff that I could only do in R, I was like, okay, yes, I must use R to do these kinds of models, but I wasn't necessarily like, must use R for everything. But once I realized that I could save myself hours of copying and pasting, I was like, wow, this is really cool. So, yeah.
So what's next on your skill set list? What do you want to learn next?
I really want to learn more about Shiny. I don't know if you've talked with your class about Shiny at all.
Much about it, but
The shiny guys come, there's like.
the shiny guy, which shiny
There's
guy?
a guy, he comes.
Oh, wait,
Yeah.
he's coming to campus? Holy crap!
Yeah.
How did I not know this?
Yeah, Hadley's coming to your campus. I'm really jealous.
Okay, clearly I have been out of the loop, like literally, so. you
I
guys
saw it
have
on
to tell me
Twitter,
these
so.
Maybe next week.
Oh crap, I'm out of town half the week. Tell him to come later.
He's written a lot of packages that are important.
Oh yeah, Hadley Wickham is kind of the R god.
Yeah.
It's on Wednesday.
Oh crap, I'm flying back on Wednesday.
What's like at 5?
It's at,
It's in the evening.
yeah, it's like 6 to 8 or something.
Let me check when my flight is.
Well, if it's in the evening, maybe he'll still be around Thursday morning and you could grab him or something.
Yeah,
So.
possibly. Let me. Okay, Fly Delta app. Okay, let's see. Oh, I can't believe I didn't know that. Oh, that's hilarious.
Yeah.
Yeah,
So-
how much do you know about Shiny?
Yeah.
Do you want to give them a little bit of a rundown about Shiny while I check to see when my flight is?
I mean, I know that you can use Shiny to build interactive like things that people can use. And you can use it to simplify people basically interacting with some kind of stuff behind the scenes in R. And a lot of people use it to create like interactive graphics. But for me, I would be using it to create some kind of interactive way of ranking proposals. And it would be a tool that you wouldn't have to know how to use R to use. But if you did know how to use R, you'd very easily be able to kind of pull back the curtain and see what was going on underneath to understand kind of the mechanism behind everything. And I would really like to incorporate some kind of interactive graphic component, but I don't know that much about Shiny yet, but I know I'm going to be learning a lot in the next 2 years, and I'm excited about that because I've seen some really cool implementations of it. So.
Yeah, it sounds like a really cool thing. I had sort of had plans. So with this Firefly phonology model from the last version of this class, it would be actually relatively trivial to take weather forecasts, like sort of extended weather forecasts, and put the model in. And then for different areas, people could say, well, we expect the Firefly peak to be around here. So that's when people would know to go out and collect fireflies. You know?
That would be pretty awesome.
So Shiny is essentially, it allows you to shell your analysis into a extra reproducible mode that non-R people can easily adjust parameters and whatnot.
It's kind of like a GUI where you say, okay, well, if we change this parameter, what would happen to our plot, for instance?
So it allows you to hide all the nasty code and specifically show.
Code's not nasty.
Well, I mean, it's for my PI, right?
Yeah.
So,
Yeah, I'm sure that that's something that you'd really love to be able to show an end user too. It's well, if we get another rainstorm, do we expect to see fireflies peaking earlier or later?
Yeah.
You can have sort of radio buttons or places to enter parameters and change a function or give a result in sort of a clean way.
all through the R execution environment.
Yeah, exactly.
So you can execute it in RStudio and it gives you the GUI and stuff
Mhm.
in there.
Yeah, and you can actually build it into like a website and have it available online that people can access, or you can give them the tool in another format. So, yeah, It's really cool. So Christy, are you going to be able to see Hadley's talk?
So I'm arriving in Detroit at 5 minutes to 5.
Oh, you
Yeah. And then I will have to drive back from Detroit, and so that's about an hour and 15. I will probably be really, really tired at that point.
But you get to see Hadley, so.
Possibly Kelly from many airports.
Yeah.
So I don't know. I'll see what I can do, but it seems low odds right now.
That's unfortunate, but understandable. Yeah.
What's your experience with like the broader professional data science R using community? Like the non-academic world.
I actually kind of started to dip my feet into that a little bit about 6 months ago, when I was applying for postdocs and not getting any interviews. But then that changed. I got to know quite a few people who work for a pretty wide variety of organizations, from Stack Overflow to Etsy, that do data science and do it in R. And it seems, I mean, it was something that I was very interested in kind of pursuing if I wasn't able to keep doing ecology. It sounds like it can be really rewarding, and like for the most part, it's a really good community of people, and you can make really good money. So, you know, that's not a bad combination of things for a job. From talking to folks, it sounded like if you're coming out with kind of a not data science degree, so coming out with some kind of, you know, ecology related degree, it would be really helpful to get those kind of jobs, to have some kind of track record online of doing R or doing some kind of open science. And the best way, they said, to demonstrate that is by having a GitHub profile and having some kind of tool or analysis or data set that you maintain on GitHub, just so that people can go and kind of take a look at how you work and show that you've been doing it for a while. But that's kind of the limit of my knowledge. I know quite a few people who do it, and they seem to really enjoy it. So I'm sorry.
So if there are no jobs in ecology in the next few years, there are potentially options.
Yeah.
So fingers crossed for all of us.
Yeah. I mean, and some of the people I talk to do like consulting for like nonprofits. So they're like helping these really cool causes do data analysis to like help inform, you know, women's issues in Southeast Asia, or help with like agricultural production in Central Africa. So it's not just like selling your soul to a corporation to make a corporation a bunch of money. You can also use it to like, you know, help people, which is cool. Or at least that was something that I found very attractive. Maybe you would like to just sell your soul to a corporation, and that is, of course, your choice. So
that's generally the ethos of this group. Yeah. Well, I think that this is probably a good time to wrap it up, because we've only got a few minutes before the next class is going to come in. But thank you so much, Auriel. It was so great to have you. And
yeah, thank you. Sounds good.
See everybody. Okay, I'll hang up now. Bye-bye.
Bye.